Hello class, in this video we're going to be looking at exact values. The learning intention of this video is for us to be able to recall the exact values of sine, cosine and tangent for common angles. So the first thing that I want to go through is explain to you guys what an exact value is and what it actually looks like. So a number that is said to be expressed in exact values is one that does not show any recurring decimals. So for instance, the number stops, it doesn't continue on, okay? These exact values are precise numbers, and we know they're precise because we can say it with a high level of certainty, a high level of confidence, and we can actually find these answers without actually using the calculator at all, because oftentimes when you do use a calculator, the calculator would give you the answer in decimal form and that number may keep on going, okay? Now, exact values could be expressed either as a whole number, a fraction, or a surd, and only for a certain number of decimal numbers are considered to be exact, okay? So for instance, 0.5, because it's just 0.50, it keeps on going as a 0, we can refer to that number as an exact, whereas a number such as 0.6666, which keeps on going, which is a recurring number, this particular decimal over here is not considered to be an exact value. Let's look at another example of what an exact value would look like. So over here, I've got an example where you'd have to actually use Pythagoras theorem to find out the length of the hypotenuse. So this is Pythagoras theorem over here. Substitute your values in. And what you do now is just square it. So 6 squared is 36, 7 squared is 49, add them together, and then you take the square root to solve for x, okay? Now, this number over here, number is a surd, and this is what we would say is in exact values. However, if you did want to use a calculator to find out what this actually equals to, then this over here would give you an answer of 9.27195, and the number keeps on going repetitively. And as a result, this number is not considered to be an exact value. See whether you can answer this question over here. Give yourself 1 minute and then we'll compare our answers together. So for this particular question, you need to identify a number that is not expressed in exact value, okay? And the answer for this question over here is going to be option C, because this dot over here indicates that this one just keeps on going repetitively all the way to infinity. So therefore, that is not considered to be an exact value, okay? All the other ones are considered to be exact because those numbers stop or they are expressed as a fraction. So now we're going to be looking at exact values in the context of the unit circle or for circular functions. So if you're trying to find the sine, cosine, and tangent of many angles, this will not result in an exact value. Only certain angles within the unit circle will result in an exact value, and generally they are going to be multiples of 30. So multiples of 30 would be like 60, 90, 120, 150, you get the idea, 45, 60, as well as 90, okay? So if you look on the image on the right hand side over here, I'm just dragging the angle sizes, and only when you reach these certain angles over here, which is, 30, 45, 60, 90, 120, those angles will result in exact value. As you can see over here, notice that these values over here can be expressed as a fraction, which indicates it's an exact value. So what this would actually imply is that you can't really find what is the exact value of sine 50 or cos 50 or tan 50. You can't do this by hand, or you would have to find out what that actually equals to using a calculator, and that won't give you an exact value. That will give you some decimal number, okay? So I'm going to now show you how do you actually find the exact values of angles that are found around the first quadrant without using the calculator, and it's really important that you know how to do this without using the calculator. So please don't try to use a calculator for the remainder of today's lesson. So what I have over here is something referred to as the exact value table, and it shows you all the angles between 0 degrees all the way to 90 degrees, okay? And generally speaking, you're expected to memorize every single value that is shown in this particular table over here. Now, you might be complaining and say, yo, this is like a bit of, this is a lot of numbers. How am I going to remember all of the exact values for sine, cosine, and tan? So I'm going to show you a few tricks that helps me memorize the exact value table. But first, before that, I want to quickly go over the radians and degrees equivalent, okay? Just in case that you still haven't mastered how to convert between degrees and radians, okay? So it's really important that you recognize that, for instance, pi on 6 is the same thing as 30 degrees. So what I have up here is on the right-hand side is the first quadrant, okay? Now, in order for you to identify what the radian form of 90 degrees is, let's just think about a circle first of all. We know that in a circle, this is 360 degrees if you go around and rotate fully. And that's equivalent to 2 pi, okay? So if you know that 360 degrees is equivalent to 2 pi, half of 360, so a semicircle, will therefore be 180, and half of 2 pi, which is, in this case, will therefore be just equal to pi in this case. Since you've got a quarter this time, it would make sense that this would be half of a semicircle. So therefore, this is going to therefore be pi on 2, because half of pi, if you divide it by 2, that will give you pi on 2. So that kind of makes sense. So using that same logic, we can therefore find out what is the radian equivalent of 45 degrees. In this case over here, 45 degrees is exactly half of 90. So therefore, if you just half this number over here, that will give you the radian equivalent. So if you just go pi on 2, divided by 2, that will give you pi on 4. And remember, when you're trying to divide, this can be rewritten as 2 over 1. So therefore, if you flip it around, so it'll be pi on 2 times 1 on 2. Therefore, that will give you pi on 4. So that's how I got the radian equivalent, okay? And obviously, if you add 245 degrees, you will therefore get your 90 degrees. In order to find out what is the radian equivalent of 30 degrees and 60 degrees, I want you to consider how many parts, or what is the ratio of 30 to 90. In this case over here, I'm hoping that you guys can see that if you kind of divided your right angles 3 times, that will give you 3 30-degree angles, okay? So therefore, if you know that 30 degrees is a third of pi on 2 or 90 degrees, then all you need to do is just go pi on 2 divided by 3, okay, and that will give you the radian form of 30 degrees, okay? So again, what we do is, because it's division, we flip it, and then we change the sign to a multiplication, and therefore we'll just multiply things horizontally. So therefore, in this case over here, 30 degrees is the same thing as writing pi on 6, okay? So that's going to be pi on 6, and in this case, if you add in another 30 degrees, so if you add in another pi on 6, that will give you 60 degrees, right? And if you add these two fractions together, that just becomes 2 pi on 6. Simplify, that becomes pi on 3. So that's how you get this particular number up here. And obviously, if you add this number again by pi on 6, okay, then what you'd get is 3 pi on 6, which will therefore give you pi on 2 when you simplify that as well. So that's the first thing I want to show you. Now that we've kind of gone through what is the radian equivalent for these common angles, let's look at what are the exact values of sine, cosine, and tan. Now, the first thing I want to point out to you to help you guys memorize this is the patterns between the exact values of sine and cosine. So there is a particular pattern over here. I want you to look this carefully and tell me, what do you guys notice between these values over here? If you have answered this correctly, then there is a pattern, and the patterns are pretty much the reverse. So notice over here, sine of 0 degrees gives you 0, then it gives you half, root 2 on 2, root 3 on 2, and then 1. Whereas if you go in the opposite direction, this is 1, 1/2, like this one over here, root 2 and 2, root 3 and 2, and 1. So it's occurring in the opposite sequence, okay? So this will actually help you, because therefore, if you actually just memorize sine, then you could easily memorize cosine, because it's going to be in the other order, okay? Now, the next thing is remembering the exact values of tan theta, okay? Now, personally for me, I've never memorized what was the exact values of tan theta, because I just have a very bad memory, okay? I can't really learn numbers that don't really have any significance. So instead of memorizing the exact values for tan theta, what I do instead is I just remember what was the formula of tan theta in terms of sine theta and cos theta. I know that tan theta is equal to sine theta divided by cos theta. So therefore, if I know sine and cos, then I could therefore just substitute it in and then work out tan theta. So I'll show you an example, okay? So say that I want to find what is tan pi on 6, okay? So I know that pi on 6, that's 30 degrees, okay? And as you can see over here, tan of pi on 6 gives you this answer, but I'll show you how you can arrive to the answer by just recalling what was exact values of sine and cos pi on 6. So sine pi on 6 is equal to a half. Cos pi on 6 is equal to root 3 on 2. Okay, so that's what I've done over here. I've just substituted the values in. And in this case over here, you're probably thinking, how do I do this by hand without using a calculator? And I'll show you a tip. So if you're dividing two fractions together like this, what you do is you multiply the outside numbers and that will become your numerator. And you just multiply these inner numbers and that will become your denominator. So if you do this, then that will become something similar to this over here. You could therefore simplify the fraction now to cancel out the 2. So therefore your answer is going to be 1 on root 3. You're probably thinking, isn't that a different answer than this? And in this case over here, although it does appear different, these numbers are exactly identical because all they've really done to get this number here is that they've actually rationalized the denominator, which means that they got rid of the third by multiplying this by root 3 and multiplying this by root 3. And therefore, if you multiply these two together, that will give you root 3 on 3 over here, and that's the exact same answer as this. So that's how I personally remembered the tan theta, but obviously if you're really good at memorizing, then just memorize the values of tan like so. Now you're probably still thinking, all right, so this is still a bit hard for me. Is there another way for me to remember the exact values more easily? And there definitely is, and this is the way that I personally learned what was the exact values, okay? And this really works for sine and cosine. Similarly for tan, you just have to either memorize it or use what I've done where I just substitute the values of sine and cosine into the formula. So I want to show you how this left-hand rule works. So this left-hand trick over here will help you memorize the exact values for only sine theta and cos theta. So each of these fingers in your left hand corresponds to a common angle that lie around the first quadrant, okay? So it starts from 0 degrees, then 30, then 45, then 60, and then 90, okay? And obviously you should also know what is the radian equivalent as well. So now that you know that, to use this method over here, what you would do is that you would need to put one of the fingers down that corresponds to the specified angle that's outlined in the question. So what that means is if it was asking me to find out sine 30 or cos 30, and you're going to be putting down this finger over here. And the number that is substituted into the numerator, so into this part over here, it depends on the number of fingers that are either found to the left or right of the finger that you actually placed down, okay? So that probably doesn't make any sense right now, but I'm sure that once I've gone through a few examples, you'll see how this particular trick actually works. So what you need to know is that if the question wants you to find sine 30 or sine 45 or sine 60, what you need to do is you need to put down the finger at the specified angle and then substitute the number of fingers that are found towards the left, okay? So that's what this particular diagram is showing. In contrast, if a question was asking you to find the cosine of one of the angles specified here, what you do is you would substitute the number of fingers found to the right of the finger that you place down. Now, sometimes when you actually substitute a number into this particular third over here, you will need to occasionally simplify the third, or you might need to actually simplify the fraction when applicable. So for instance, if there's no fingers found to the left of the finger you place down, then obviously the square root of 0 is still 0, so you don't have to write square root. Similarly for square root 1, that's the same thing as 1, and square root of 4, you need to simplify that to become 2, okay? So let's go through 2 examples, and I'm hoping through these 2 examples you're going to be a lot more better at finding the exact values. So the first question wants us to find the exact values of sine 90 degrees, okay? So in order for us to do this method, because it's asking for us to do sine, so notice over here I've done this sign on the left hand side, so this means that you have to read towards the left. So you have to count the fingers found towards the left when you put one finger down. In this case over here, because I'm interested in 90 degrees, I'm going to be putting down 90 degrees. In this case, I can't show it to you physically, so I've kind of cut the finger off. In this case over here, you need to count the number of fingers found towards the left of the finger that you've kind of placed down. So in this case over here, it's going to be 4. So therefore, if you put 4 over here, Therefore, your answer is going to be, square root 4 on 2. You can simplify square root of 4. That in this case, that's going to be 2. And you can simplify this fraction. So therefore, sine 90 degrees is equal to 1. That's the answer in exact values. Let's go through another example. So in this example over here, you're trying to find the exact value of cos pi on 6. Remember, as I said, you need to know what this is equivalent to. So this is the same thing as 30 degrees. So again, I've got my hand over here. Because it's cos this time, I'm going to be counting the number of fingers found on the right-hand side, okay? And in this case over here, because I'm interested in pi and 6, I'm going to be putting down 30 degrees, okay? So therefore, I count the number of fingers found to the right of the finger I put down. In this case, it's going to be 3. So therefore, this will be my answer. Can you simplify this any further? No, because there's no perfect square that goes into 3. So therefore, you're going to leave this as an answer over here. Now, I haven't shown you how to do it for tan, but the strategy for you to find the exact values for tan is that you just need to memorize sine and cos, and then substitute it into the sine theta divided by cos theta formula. So have a go with answering this question over here. One of the questions will ask you to do tan. Give yourself 5 minutes to answer these questions, and then we'll compare our answers together. So if you guys have done this successfully, what you will need to do first is, if you were using the left-hand rule, you'd be putting down pi on 4. So therefore, you'll be putting down 45 degrees. Which I've done. Then count the number of fingers found towards the left, because sine is found to the left. And in this case over here, there are 2 fingers, so therefore my answer is going to be root 2 on 2. I can't simplify any further, so that will be my final answer. Now, in this case over here, in order for you to find out what is tan pi on 4, which is tan 45, I need to find out what is sine 45 and cos 45, okay? So I've already found out what sine pi on 4 is from the previous question, so therefore all I really need to do is find out what is cos pi on 4. So the same thing applies. You would be covering this finger over here, but this time you just be reading towards the right hand side. So in this case, there are 2 fingers on the right hand side, so your answer will still be root 2 and 2. So if you substitute the values in, if the same numbers are being divided by itself, that will just equal to 1, right? So therefore, this will be the answer for this particular question. Now, so far, I've shown you how to actually, recall the exact values for sine, cosine, and tangent of common angles found within the first quadrant. I'm now going to show you how to do this within the second, third, as well as the fourth quadrant. In order for you guys to do this part, it's really critical that you guys understand how to actually find the exact value of the first quadrant. Otherwise, this will become a bit more difficult, okay? So, because there are symmetry within the actual unit circle itself, we know that a circle is a symmetrical shape. This property will allow us to find what is the exact values of certain angles by understanding how reflection changes the sign for that particular exact value. That probably didn't make any sense at all, so let's go through some examples to make this more sensible for you guys. Okay, so in this case here, let's just take 5 pi on 6 as an example. Okay, so 5 pi on 6 is the same thing as 150 degrees. How do I know that? Well, if I know what pi on 6 is 30 degrees. I just go 180 minus pi on 6, therefore that gives me 150, okay? So that's found over here, okay? Now, in this particular case over here, in order for you to do this, that's the same thing as, in this case, pi on 6. This is a angle that I am more familiar with, okay, with 30 degrees, and I've done that previously, okay? So I could use my understanding of what is the exact value of pi on 6 and then use the properties of symmetry and reflection to get me the answer of sine 5 pi on 6. Now, if you guys remember, sine refers to the y values of the coordinate and cos refers to the x values, right? So in this case of it, it's pretty much saying what is the y coordinate when it's at 150 degrees. In this case of it, you can clearly say graphically, because I've got the graph in front of you, that in this case of it, your y values is going to be exactly the same. It's going to be 1/2, but I'll show you how to do this in a more in a way that doesn't actually involve the graph at all. So in this case over here, we know that 5 pi on 6 is a reflection over the y-axis from pi on 6, okay? So this is where pi on 6 is, and you could actually get the same angle by just flipping it to the other side over the actual y-axis, okay? And when you actually flip or when you reflect over, what happens is that your y value will still the same because it will still remain at the same height, but obviously your horizontal distance has actually shifted, okay? So this in this case, instead of going from a positive number, you're now going to a negative number when you reflect over the y-axis, okay? So in this case, if I was trying to find out what is sine 5 pi on 6, the exact value of sine pi on 6, if you guys remember, is 1/2. So in this case, because I'm flipping it over the y-axis, y remains the same. So therefore, this answer still remains as half, okay? But in terms of cos 5 pi on 6, because I am reflecting, cos pi on 6 is equal to root 3 on 2. But now because I'm flipping it into the negative side, therefore, this is going to therefore be negative root 3 on 2. So all you're simply doing for some of these questions is you're relating it back to the exact values of the first quadrant, but you might need to change the sign in front of it, okay? Let's go through another example. So I've got 5 pi on 4. So 5 pi on 4 is over here. It lies within the third quadrant. In order to get to that, what you could do is you could start off from this angle over here, an angle that you're more familiar with in the first quadrant, and you could reflect it a number of times in order to get to this position. What you do is you reflect it over the y-axis to this side here, then you reflect it again over the x-axis to get this value over here, okay? And by doing so, what this does is by reflecting over the y-axis, your x value becomes negative, and your y value also becomes negative because you reflect it over the x-axis. So in this case, I know that sine pi on 4, if you guys remember what this is, that was root 2 on 2, okay? Now, by doing all these transformations, your x value becomes negative and your y value becomes negative. Since sine is associated to y, the vertical height, then your answer is going to be negative root 2 on 2. And since your x value also becomes negative, then the answer for this one will also become negative root 2 on 2, because cos pi on 4 is equal to root 2 on 2, and all I did was just chuck a negative sign over here. Now, this explanation over here may or may not make sense to some of you guys, so there is another way of answering this question over here. So for this one over here, recall that we previously said that each quadrant was positive for certain trig ratios, okay? We said that within the first quadrant, sine, cos, and tan of those acute angles will always be positive, but in the second quadrant, only the sine of those angles will be positive, everything else will be negative. For the third quadrant, tan will be positive, and the fourth quadrant, cos will be positive. So therefore, if I was trying to find out what was sine 210, what I would do is I would firstly identify what quadrant that lies in. In this case, if it lies in quadrant 3, we know that in this case over here, sine is negative in quadrant 3. Only tan is positive, okay? And because this is negative, what you now need to do is find out what is the reference angle. So the reference angle is 30 degrees, because if you go 30 this way, that's the same thing as going 30 this way. So these angles are somewhat equivalent, you could say. And in this case over here, because we know that sine is negative, that's the reason why I've included a negative in front of this part over here. So if you know what sine 30 degrees is, then you could actually find out what is sine 210. In this case, sine 30 degrees, if you use your hand, that's equal to pi on, that's equal to 1 on 1 over 2, so half essentially. So therefore your answer is going to be negative half. Let me go through one last example with you guys. So in this question asks you to find the exact value of 315. 315 lies within the fourth quadrant. And in this case of here, I know that tan is also negative in the fourth quadrant, okay? So therefore, you will have a negative answer. Now, I just need to find out what is the reference angle. And by knowing what the exact value of the reference angle, I just need to chuck the negative sign in front of it. So your reference angle is going to be 45, because that's 45 going this direction. This is 45 going in this direction over here. So if you guys can recall, what was the exact value of tan 45? That was the same thing as 1. So therefore, add a negative sign, your answer will become negative 1. Have a go with answering these questions over here. Give yourself 5 minutes, and then we'll compare our answers together. So for the very first question, it says find the exact value of sine 120. 120 lies in the in the second quadrant, and because I'm trying to find the sine of the angle, I know that my final answer will become positive. The reference angle over here, as you can see, is equal to 60 degrees. So if you know what sine 60 is, then that's going to be the same answer. So sine 60 degrees is equal to root 3 on 2. For the next question, cos 330. 330 lies in the fourth quadrant, and I know that cos is positive in the fourth quadrant. The reference angle in this case over here is equal to 30 degrees. So I just need to find out what is cos 30 degrees. Cos 30 degrees is equal to root 3 on 2. So that's going to be my answer for this question as well. And for the last question, tan 150 degrees. 150 lies in the second quadrant. I know that the sign is only positive in that quadrant, so therefore your answer for this question will be a negative. So I should just write, oh, that's a typo, that is tan is negative. And in this case over here, your reference angle is going to be 30 degrees because you move 30 this way, you go 30 this way. So if I know what tan 30 is, I just need to add a negative sign into my final answer. So tan 30 was equal to root 3 on 3. So my final answer will become negative root 3 on 3. So there should be a negative sign over here as well. What I'd like you to do right now, guys, is I'd like you to please answer these questions up here. These are all the questions I'd like you to do. And that's about it for today's lesson. Hopefully you're able to meet the success criteria of today's video. Thank you for watching. I'll see you guys again in the next video. Bye.